Okay, now we look at level rules. Application of level rules is that we find the weight percentage in any two phrases region in a binary system using the level rules. So this is a simplified diagram. We consider a binary system, meaning you have two elements there. So in this case, this is just a simplified diagram, temperature, and you look at the x-axis first. X-axis from 1 to 0, 0 to 1. 0 to 1 means you can take as a weight fraction. So 1 means 100%, 0 means 0%. So in here means B, weight percentage of B means you focus on B, right? So what is level rules? Level rules, we focus on this level, means this straight horizontal line. Okay. So these level rules have a few distinct characteristics. So we focus on, you give you one temperature, you enter the graph from one temperature, you use your graph, draw a horizontal line. That horizontal line will cross liquid line and solid line. Okay, you do this one, then you drop down. The liquid line, you drop down to X, you get percentage in liquid. Then you drop down S, you get percentage in solid. Then at point O is the X that you want to find, right? So we are going to use level rules to find the exact position of this one. Okay, how? So let's say we want to find a value at this. So we put an X, this one, and the weight percentage you can put as WX or WO. Just label as a point O. This is what we want to find. Because when you do in your process, you fix your temperature. When you fix your temperature, and then you don't know, when you fix your temperature and you observe your product, or in your process, you're seeing liquid and solid phase, but you don't know how many percent of A, how many percent of B. You use these rules, you use level rules at a certain percentage. Then you fix again, you look at the temperature of your interest, you fix that line. This is called timeline. Okay, draw timeline. So I will write something on the whiteboard. First step. Okay, first step. We have liquid and solid line, temperature and weight percentage. Okay. First steps, you enter the graph with horizontal line, which is the temperature of your interest. Okay. Then step 2, okay, this is called timeline. Then at temperature, you don't know whether how many percentage of solid and liquid, right? So the 3. The 3 here, it will tell you how many percentage of that. Okay. So if later give you the steps here. So the first rules, we use weight balance, which is X percentage of liquid plus X percentage of solid, we get 100%, right? Meaning you take this one plus this one is 100%. Means weight percentage at that point, you should have 100% of weight, right? Okay. What does it mean? What does it mean? This one. I flip back the previous slides. Make this one a bit bigger. Okay, so if you look at this graph, if I pick this point, okay, I pick this, okay, this point. At this point, you will have 100% solid. This point, you will have 100% liquid. But between here, you don't know how many percent of solid or liquid. So you use your X solid liquid to get the 100% percentage. So first equation in level rules is X L plus XX equal 1. X is the weight percentage. Weight percentage of liquid and solid get 1. Then we focus on liquid. You rearrange the equation. You push the solid to the right-hand side. Or you can put your liquid to another side. But this is the fundamental equation we use. Okay, then you start to do a little bit of chemical calculation. So you put 1 gram or 100 gram, doesn't matter. So in this case, we just put 1 gram of alloy. So 1 gram of alloy to make this a weight balance. So gram of B in phase, in 2 phase will be gram in liquid and phase, right? So 1 gram will be have some how many percent of liquid, how many percent of gram of in solid, right? So 1 gram, you times percentage of W divided by 100 will equal. This is weight percentage of phase mixture, this one. All right, this is average fraction. You take the XL here, multiply by percentage of weight percentage, plus the solid percentage. Okay, you change this equation with gram in gram by using this mathematical calculation. Okay, you put in 1, and then you use the fraction. Okay. You convert the above equation into this one. This side will get this one. This term will become this one. This term will become this one. Okay, recall this equation that I wrote on the whiteboard. We are more interested to put in one term, so we will convert the equation in only one phrases. XL equal to 1 minus XX. So you substitute this with this one. So inside this equation, you only see solid phrases. Right? Not solid phrases, but concentration of liquid is in solid. Means how we apply this one. Normally, the question will give you X percentage of solid. Then from here, you only need to take this one minus 1. You get the percentage. So we look at tutorial later. Then this one will become clearer. Right? So you just simplify this equation. So this one multiplied by this one, and yeah. Okay. So you rearrange, you get one equation. Okay. Now don't worry about this one, because later I'll show you one tutorial question. You will do the same steps also. Okay, you do the same steps also. This is mathematics steps. Then you derive using this equation. Then you simplify. You simplify. So you get weight percentage is solid. You factor this one out. You factor XX. You get left hand side, you get WS minus WL. You move to the right, you get the fraction. Right? So, or you can memorize, huh? WO minus WL, WS minus WL. Or you can memorize the O as the X, the one that you want to find. What does it mean? If you want to find fraction of solid X minus XL, what does it mean? You take this point minus this point, which is this length over the total length. WS minus L is the total length of this one. So this one, the ratio of this one is the weight percentage of your solid phase. This is to find the ratio. You take this one with the total length, you get weight percentage for solid phase. Then same. This one with total length, you get weight percentage of liquid phase. Or once you find this one, you take 100% minus this one, you get the liquid phase. Because total, you only have 100%. Same, huh? You can either use any one, huh? Either you find the liquid or solid first. Same, huh? But you means that you only need to memorize one of it. Then you take 100% minus that, and you get another one. But if you hardworking, you can do the same. You still get the same answer. Okay, we look at okay, this is called Leverous equation. Either this one or this one also same, right? So this is called tie line, and you are using this tie line to apply the Leverous, and this one is important for incoming assessment. It's important, huh? Okay. This is just a simplification of what I explained just now. 8% weight fraction, you just multiply 100 lah. This one is the ratio, you get 0 point something. You times 100, you get back the percentage. Okay, let's do this exercise. Huh? So, okay, derive Leverous for this case. Okay, this one is actually flip of this graph. But so it means that there's no fixed way of doing it, but the Leverous still same. So let's do, you see the phrase is different. Huh? Liquid is on the top, bottom is a solid, and liquid solid. So to derive the rules, okay, you know that this is liquid, this is solid. Just now, liquid, solid, you flip the thing. So to find the solid, you take this one, divided by here to here. Okay, the solid one. Solid is in front, always near to the liquid. Same with here. If you take this one and this one, that is liquid percentage. Yeah, so this is your homework. You go and derive it. Yeah, so it's a flip from what I write on the whiteboard. Not flip. Is it the same? You derive you derive. Okay. Yeah, correct. Liquid is near to the solid. Solid one is near to the liquid. Okay. You give the number, right? You'll see a more proper graph. but this is just a simplified graph. Okay, this one, then you'll see something like this in the exam. You see numbers. But the step is same. The step is same. Okay, let's do example 2. Then I think we call it a day. Okay. Now, okay, you look at the diagram. First, you have to identify how many elements inside. This is 2 elements, nickel and copper. Then after that, you look at how many phase you have. Liquid alpha. What is alpha? Alpha is solid. So you have liquid and solid. You have 2 phase, and then there's one mixing of this one. Okay, then you look at the question. Nickel copper content 47% copper and 53% nickel at 1300 degrees C. So of course this one is give you easy already lah. It already give you the temperature. But in task you won't see this one. I will remove this line. I will change the temperature. So for example, I shift this one down or up. Same procedure. You just draw a straight line. Then draw down, draw down, draw down. Draw to get the percentage. Okay, I just illustrate with one temperature. The question always fixed as one temperature when it comes to phase diagram. So here, if it fixed at 1300 degrees C, and it tell you the alloy content 47 and 53% nickel, you need to find where is this point. So use the figure below, answer following what is the weight percentage copper in liquid and phase for this percentage of alloy. What is the weight percentage of alloy in liquid? What is the weight percentage in solid? So important temperature, you draw the temperature straight line. Then, okay, I'll give you the steps. So in the straight line, it give you 55%. Wait, 55. Copper, 45%. Correct. This one is copper. 55% copper is correct. Means 45% nickel. It's two element. So it will give you, because this one it give you 47 ma. But when you draw the line, you will meet in liquid phase. You identify where is your liquid phase first. Where is the solid phase first? Okay, then you drop down. Because this is the length of your ruler, of your level rules. Okay. So give you this one, and the intersect of solids give you 42% copper. Why? Why we focus on copper? Question give you copper. Question asks you to find copper and not nickel. So you focus on copper. You don't go and do nickel because the question asks you what is the copper percentage for that one. If you do nickel, then nickel lah. If the question asks nickel, then you change to nickel. So here we focus on copper. So we stop at 55 at liquid, and another one is how many percent? Here, solid one is at 42% copper. Okay, 58 is nickel. We focus on copper now. So we have 2 points there. Then we start to do analysis. So the question gives us 53% nickel. 58% nickel, 53% nickel. Actually, it's the same lah. It's the same. Only you need to move down only. Okay. 53% nickel. Okay, WO is this one. Okay. So fraction of solid phase. Why you go and do nickel? So you have 2.58 and 45 nickel. Then for solid phase, you know solid phase is here and here, ratio of this one and this one, right? I mean, you near to the liquid one is the solid fraction. So this one and this one. Or you can use the equation LO minus WL. So you take this one, the question X here, minus this one, because as you move to the right, the more percentage, so you take the positive, the higher number minus the lower number, and you take the higher number minus the lower number, you will get 0.62. Yeah. Yeah. So for binary, actually you can focus on copper and nickel same. Because if you change, for example, for two line there, this point on liquid line, we have 45% nickel and 55% of copper. Same. This point, 58% of nickel and 42% copper. Then at this point, this is the X. The question asks you this position. So the question asks you 47% of Cu and 53% of nickel. So no matter you use nickel or copper, the liquid or solid phase that you find still same, because you are looking at point. Understand, huh? I think the slide I should not show you the copper. I should not show you the, yeah. Okay, but it's still the same point. Same point, huh? So don't confuse by the nickel and copper percentage. They're actually the same point. Okay, once you get 60.62, you times 100, you get the weight percentage. You do the same. Once I know the solid, I know my liquid is, I take 100% minus this one. I get like 38% of liquid. You can do the same calculation if you want. You get 38%. Okay. Yeah, can. Okay. Maybe one more. Okay. Same. You look at this diagram. Before you do anything, you look at diagram. Temperature always on the left, but this one is Fahrenheit. No issue. Fahrenheit, no issue. Actually, sorry, Celsius. Why got Fahrenheit here? Okay. Never mind. We just look at Celsius and percentage of silver. Here you have PT and AG. Right? PD and AG, you know that 100% AG here and PD 0 here. Right? So we are AG is silver lah. AG is silver. So you always focus on the right hand side. Okay, calculate percentage of liquid and solid of AgPD phase diagram at 1200 degrees C and 70% Ag. Assume percentage of Ag in liquid phase is 74 and with percentage of solid phase is 64. We want you to find percentage of liquid phase. So first step, always draw a straight line according to temperature. So here, the phase, liquid phase here, solid phase here, and then here is a mixture between two. Okay, you draw a phase, a line, 1200 degrees C, and then the target, it tell you the target is 70% of Ag. So you find Ag, work back 70%, draw another line. This is your X. This is the X point. Okay, X point. Here, this is liquid, this is solid. So you know that percentage of solid, you take this one and this one. Then you take 100 minus that one, you get another side. Okay, so you can go deeper, go down here, 100% of 74 liquid, 64% of Ag on the left-hand side. So this is your X, right? So percentage of liquid, you take XL minus 100. So you take percentage of liquid is 70, your target. Your target liquid is here and here. Okay, liquid, this is liquid solid so you find liquid means near to solid. Take this one 70 minus 64 and 74 minus this side is liquid. This side is liquid. So look carefully on the phase diagram. Okay, so the trick always the same. So you draw the tree line, then you identify where is your liquid, where is solid. So if you want to find percentage in liquid, you go to the solid side, then you find the length, then compare to the total length. So here 6/10 is 60%. So you know that percentage of solid is 100% minus 60 is 40%. Make sense or not?
Yeah. Before is for solid or liquid? Solid.
Solid.
So I have
No, you this one you look back at the diagram because this formula is flipped already. This formula is for liquid this side, solid this side. You cannot use like one formula for that, but the principle still same. The one that near to the solid is always to calculate liquid one. Understand? Right. You remember that one? You find the length between the X and the solid. That one is to calculate the another one. Here to liquid is to here to solid is to calculate liquid percentage. Then here to here, because this is liquid is to calculate another side, another type is calculate solid one. Understand? Okay. The rest is same lah. Okay, so I flip back. If you what you learned just now, I flip back and you look, observe the graph. Liquid on the top, solid on the right. Then I flip here. Liquid here, solid here. Liquid here, solid here. So liquid here, solid here. You draw a line, temperature. So this is liquid. Liquid to the X to find what? Solid because it's near to solid near to liquid. Then here to here is to find what? Here is solid so you find liquid percentage. It's always same. Then you flip back to the previous one. Here. Okay, this one same. Example 1. Example 1. Okay, example 1 is just a derivation. So you see, solid, liquid, we have 3 points. You draw temperature, level rules. Then you want to find percentage of solid. You look at the liquid, then liquid to the X, this one to find your solid. Then here, solid to X is to find liquid. You don't confuse by the percent. There's no like one equation for that, but you try to rationalize in the ratio. Okay, you compare the two example, like example 2 and example 3, then you see the difference. Okay. Okay. Then you reverse back to the steps just now, the derivation of the equation. See, this one I flip back already. I flip back, liquid and solid. Liquid on the top, solid on the bottom. How to find percentage of solid? What I take? To find solid, I go to the liquid to X. liquid to X. So you take this one minus this one. It's liquid to X, or X to liquid, same. Compared to the total length. Then to find the percentage of solid, percentage of liquid, I compare the solid line and the X and the total length. So here you get Wx minus O, Ws minus L. The principle still same. The graph can change, but the principle still same. Yeah. Okay. So, and this one is for binary system. Okay. Can this one got 2. What weight percentage is liquid solid? Weight. A is just to find the percentage of copper. To find the percentage of copper, you just flip to another percentage. Then B, you just use the rules. B is more on the solid or liquid. Okay. This is a very simple mathematics. Once you understand the ratio, how you find the thing, then it's no issue. Okay. Okay, I think we stop here. Okay, we continue next lecture.